Right, we now begin trying to work out how to plot a parabola. Again, it's quite simple. We just have to remember the little steps. First of all, you should always be able to look at a parabola and realize if it's a happy parabola or if it's a sad parabola. Please never draw a parabola and don't look at it and think whether you've got the right shape. Remember that we know a parabola is happy if your a value is positive, your ax squared plus bx plus c is positive, and we know a parabola is a so-called sad parabola if your coefficient of x squared is negative. Right, in any graph that you ever draw, you need to label and plot the y-intercept. Now, all of us know that at your y-intercept, x is equal to 0. Some forms of the parabola, we might remember that y is equal to ax squared plus bx plus c is a form where you can immediately see the y-intercept and therefore you don't need to show any working. If you're given the turning point equation or the x-intercept equation, you would have to substitute in x is 0 in order to work out your coordinate. Please remember to label it. Your x-intercepts are a bit more challenging. Most parabolas have 2 x-intercepts, most of them. However, don't be afraid if there's no x-intercept or if you only get one. Remember that there are various options. If you have 2 x-intercepts, it means that the graph either cuts the axis and turns below it and then cuts the axis again, or I could have the shape the other way around as the sad parabola, but either way I have 2 x-intercepts. However, the graph could turn on the x-axis, and therefore I only work out one x-intercept. It doesn't necessarily mean I made a mistake. It simply means that the graph turns on the x-axis. And then there's the option of this graph never cutting the x-axis at all, which means your graph could turn above the x-axis and never reach it, or it could turn below the x-axis and never reach it. In any of these scenarios, the methods of finding your x-intercepts are exactly the same. At your x-intercepts, y is equal to 0, and we have a quadratic equation. Now, when we do an example, we'll remember how we solve quadratic equations. Now, once you've got an x-intercept and a y-intercept, you're almost ready to draw, except you must have a turning point. And you must please plot and then label it. We do remember the turning point form of the parabola equation. Therefore, if it's given to us in this format, it's incredibly easy to immediately say, right, my turning point is PQ. Remember, there should be a minus there. So my turning point is PQ, and I can plot it, and away I go. If it's not given to you in that form, if it's given to you in ax squared plus bx plus c, or if it's given to you in any other format, for example, the x-intercept format, you would need to multiply it out and get your standard equation. You can then, as we've said before, complete the square. I don't bother most of the time. I use a formula which is not on your formula sheet, and you please must remember that the x value of your turning point is negative b in your standard formula over 2a. b, your coefficient of x, and a, your coefficient of x squared. Now, once you've got your x value of your turning point, your y value of your turning point still needs to be determined, and fortunately, they have given us a relationship between x and y in the form of an equation, which means as soon as I have x, I can substitute my x value into my equation, and I can work out my y value of my turning point. The only problem in this method is if I don't have any x-intercepts. If I get a situation like I've mentioned where my graph turns before it meets the x-axis, I can find my turning point as per usual. I can find my y-intercept as per usual, but we try to draw every single parabola with at least 3 points on it. Now I've written here, find another point. The most important thing to remember with an equation is it is a link between your y coordinate and your x coordinate at any point. So if you ever need to find any point on any sort of function, you can substitute an x value into your formula. In this case, I don't really mind what point we find. So I could pick any point. I could substitute 1 into my formula, and I could work out a y value, and then I could plot that point. I could substitute in 2, 3, -1, -2. Any point that I could plot and that could help me with my shape of my parabola. Let's look at an example. The first example says, plot the following graphs on the axis given below, labeling all intercepts, turning points, and give the equation of the axis of symmetry. Now, in every single question we do, in every function, we are going to label all important points, which often include turning points if there are, intercepts, asymptotes, etc. Right, intercepts and turning points. If I look at this equation, I realize that this is my standard form, which is useful for some things and not useful for others. Immediately, I see my a value is negative. So in my head, I'm immediately picturing some sort of sad parabola. I then also see that I have a +4 at the end of my equation, which I know in the standard form means immediately I can tell you my y-intercept is when x is 0 and y is 4. Which means I simply need an x-intercept, a turning point, and I'm ready to plot. So if I move on to my x-intercepts, they're not as easy to see. We actually have to do some hard work. At my x-intercept, my y value is 0, and I need to solve for x. Now, quick recap on quadratic equations. Quadratic equations, we always need one side equal to 0. Now, fortunately, when we're finding x-intercepts, we make y 0, and so that first step is generally done for us. Our second step is to factorize. If we battle to factorize and we can't figure out, we can always remember that any quadratic equation can be solved using my quadratic formula. So if you don't like factorizing, use your formula sheet and use your quadratic formula. I'm going to factorize. Now, the first thing I notice is I have a negative coefficient for x squared. I don't particularly like factorizing when I have a negative coefficient of x squared. So I'm going to move everything to my other side of my equation simply to get my negative x squared with a positive exponent. I could also think of it as multiplying by -1. You're allowed to multiply an equation by -1 as long as you do the same thing to everything. That would also get rid of my negative coefficient, which would make my factorizing easier. So if I think of myself as multiplying by -1, I get 0 is equal to x squared minus 3x minus 4, which I find a lot easier to factorize. Right, my two factors are x and x. I then need to multiply to get a value of 4, which I could either choose between 4 and 1 or 2 and 2. However, when I multiply out and add up my middle terms, I need to get a value of minus 3x. Now, there's no way that 2 and 2 are going to get, adding or subtracting, get me to minus 3. So I think I'm working with 4 and 1, and clearly 1 must be negative and 1 must be positive, and I think I need minus 4 and plus 1, so that when I multiply out I have minus 4x plus 1x, and I get my minus 3x. Please always check. It takes a second to quickly in your head go x squared minus 4x plus an x minus 4. I'm right. Now that means either x plus 1 must be equal to 0, or x minus 4 must be equal to 0, which means in this case I have two x-intercepts. Now I'm going to plot my information so far to see what my graph is looking like. Please remember that if they ask for the coordinates of these x-intercepts, I should technically write -1, 0 and 4, 0. Now let's go and plot what we know so far. So my x-intercept, please label it -1, 0. Even if it's on a line on your graph, please always label. And then 4, 0. My y-intercept, we said, was at 0, 4, which means if I can get my turning point, my graph is complete. Now, we've already spoken about how I can easily work out the x value of my turning point. I'm going to have a quick look. Is there not an easier way by simply looking at these two x-intercepts? Won't the turning point be slap bang in the middle of my two x-intercepts? It should be dividing my graph exactly in half. Now, where is the halfway point between -1 and 4? Sometimes it's easy to tell, and sometimes it's not so easy to tell. Now, the distance between -1 and 4 is 1, 2, 3, 4, 5 units. And halfway of 5 units would be 2.5 units. So I'm guessing, logically, that if I moved 2.5 units this way, and I moved 2.5 units this way, I will land up in the middle of my graph, which means without thinking too much, I think my x value of my turning point is 1.5 or 3/2. Now that's only my x value of my turning point. Now I'm going to go back and use my x is equal to -b/2a to confirm if my suspicion is correct. Let me erase my working. Right, now let's go back and check. X of my turning point is -b/2a. So in this case, it's already given to me in my standard form, so I can see that b is 3, -3, all over 2, and a is -1, which is -3 over -2, which, as we've predicted logically, the x value of my turning point is therefore 1.5 or 3/2, which means I simply need to do my y value of my turning point, and then I can plot my graph and I'm done. Now this part's easy. All I have to do is go and take my x value of my turning point. I need to substitute into my equation. Now I've run out of space. If you have fractions in your equations and you're not completely happy with fractions, there's no problem with picking up your calculator, working it out, and not showing. I've just picked up my calculator and I've worked that out, and I got 25/4, which, just so I know where that is, that's at 4, no, apologies, that's at 6 1/4, so I know where to plot it. So I predicted 3/2, and we've just proved that it's 3/2, and it's 6 1/4, and we label our turning point 3/2, 25/4, and I can see my predicted sad parabola shape is exactly what I've got. I draw a smooth line. Please don't draw straight lines, but a smooth curved line. Now I missed my x-intercept, so let me try again. Smooth curved line, please with arrows on the end, so it indicates this graph carries on forever. And that is my first example of my parabola.